This quick video is going to walk through a little bit of exercise protocols. One thing that I found very confusing when I was studying exercise testing was, where do you start once you have all this data? And the key to the whole thing is it's going to start with your VO2. If your VO2 isn't where it should be, if it's reduced less than what you expect, then you need to search for an explanation for why it's reduced. If it's where you expect, then you probably don't have a problem. But let's start off with the first thing you have to do is select the correct protocol for the clinical question being asked. And so you can either do a progressive exercise test or a steady state exercise test. And obviously these both have two different goals. With the progressive exercise test, you're actually going to compare the results to what you would expect the pattern of results to be as you increase workloads for a given patient. As workload is increased in increments, you're going to find the max ventilation, your max heart rate, and then if they are symptom limited, meaning maybe they don't reach their maximum heart rate because they have to stop because they have pain in their knee, or maybe because they're short of breath, or maybe because they develop chest pain. So that's, as you increase your workload, you're going to find out one or all three of those items. For steady state testing, you are assessing the cardiopulmonary function under normal conditions, or you're assessing the cardiopulmonary response to a known workload. This is what they use when they're trying to assess effectiveness of therapies, such as bronchodilators to control exercise-induced bronchoconstriction and so forth. With a steady state exercise test, a set workload is given. And you're not necessarily going to change the workload. You're going to set it, say maybe at 10 watts or whatever. And then once you find the heart rate remains stable for 1 minute, then you're going to measure the VO2 and the minute ventilation. So again, depending on what you're trying to find out about the patient, is going to determine which type of exercise test you will select. If you are doing the progressive type of exercise testing, then you're probably going to be using the ramp protocol. So we actually have a method to determine how you're going to set your ramp protocol up. So what you're going to do is you're going to take your predicted VO2 max for your patient and subtract out the patient's VO2 at rest, and then you're going to divide that number by 100. The answer you get for that is going to tell you how much watts you need to achieve in 10 minutes. So for example, if we have a predicted VO2 max of 2300 milliliters and a resting VO2 max of 300 milliliters, then we'll take 2300 minus 300, divide that by 100, and you get 20 watts per minute. So that means you would increase the workload by 20 watts each minute. If your subject has a reduced exercise tolerance, then you would reduce the predicted max workload. If you have a very fit subject, then you might increase your estimated max power output for that patient. For those with lung disease, you're probably going to use one of the methods below. If they have a MVV of greater than 80 liters per minute, you're going to use the method we just talked about, the predicted VO2 max minus VO2 at rest. However, if they have less than 80 liter per minute MVV, you're going to use a 10 watt increment. And if they have less than 40 liters per minute, you're going to use a 5 watt increment. So the more severe the lung disease, the lower the watt. Okay, let's take a quick look at the MET, or the metabolic equivalent. This is a commonly used term to describe the level of work performed during an exercise evaluation or in relation to activities of daily living. 1 MET equals the oxygen uptake at rest, or 3.5 milliliters of O2 per minute per kilogram. If the O2 consumption is measured during a cardiopulmonary exercise test, the MET level achieved can be easily calculated. So here we have an example where the patient reaches a peak VO2 of 15 milliliters of oxygen per minute per kilogram. So to calculate out the MET, you would take 15 milliliters of O2 per minute per kilogram and divide it by the 3.5 milliliters of O2 per minute per kilogram. Your answer should be 4.3 METs, or about 4 METs. To put this into perspective, healthy sedentary patients should be able to exercise up to 7 METs. Okay, I'm not going to jump into the physics of this, but sometimes it's helpful to see how work, energy, and power are all related. For example, when we talked about the increments, we were talking about the watts. So that's how much power the patient is going to use. Okay, it's measuring how quickly the work is done. It's the work divided by the time taken to do the work. So if you're running up stairs, the person is using more power. If you're walking upstairs, they're using less power. Okay, that in regards then to energy, okay, we use a MET to reflect the energy, and it's the ability to do the work or the ability to exert a force. So energy is going to be the same regardless if you're running up the stairs or walking up the stairs. It's just the ability. It's a measurement of the ability. Next, we have work, okay? And that is measured in kilopond meters, or kpm, and it equals the work of moving a 1 kilogram mass a vertical distance of 1 meter against the force of gravity. Now, we don't really talk about the work when we talk about exercise testing, but basically it's the force applied or times the distance moved. That's how physicists use it. Whenever work is done, a force is used to move something. So open a door, lift the groceries, climb the stairs, or throw a ball. Work is going to be the same whether you're running upstairs or walking upstairs, okay? So this is just how they're all related, okay? You will not be tested on this or quizzed on this. Just if you needed to put it into perspective, the difference between energy, power, and what we're talking about, sometimes pictures like this help with that, and I'm a big picture person. Okay, so let's put this to use for an example here. Anytime we have exercise testing, the first thing you're going to want to do is look at your VO2. What it was at rest, what the max achieved was, and what the percent predicted was. So for this patient, we have a patient who weighs 68.9 kilograms. He ended the test for shortness of breath. Okay. So questions we want to ask ourselves. 1, how many watts should be increased per minute for the ramp protocol? 2, how many MET equivalents were achieved? And then 3, what can we surmise from this? So first of all, let's try and answer the first one. How many watts should be increased per minute? Well, if you remember how we determine our ramp protocol, we take our predicted max VO2, which in this case, the predicted max is 1.368, or about 1,300 milliliters. And then you're going to subtract out the VO2 at rest, which in this case is about 300 milliliters. So yeah, we're rounding up and doing a little estimating here, but 1,300 minus 300, divide that by 100, and you end up with 10 watts per minute. So if we were doing the ramp protocol, we would increase every minute by 10 watts. Okay, next, how many MET equivalents? Well, the patient achieved a maximum VO2 of 863 milliliters per minute per kilogram, or per minute, excuse me. Now, to find out how many milliliters per minute per kilogram, we would take 863 milliliters, okay, here we are, 863 milliliters, and divide it by the patient's weight. In this case, it was 68.9 kilograms. And what we get for an answer is 12 milliliters per minute per kilogram. To find out how many METs that is, we're going to take our 12 milliliters per minute per kilogram, divide it by 3.5 milliliters of O2 per minute, and that gives us about 3 METs. So what do we know now? What's our takeaway from this? What have we learned? Well, first of all, our patient's VO2 was below 80% of predicted. So our next question is to find out why it is reduced. We know the patient ended her test for shortness of breath, or his test for shortness of breath, so it was symptom limited, but why was their VO2 so low? We also want to find out, why is the MET lower than normal? If a sedentary normal person can normally achieve an MET of 7, why is this person not even getting half of that? So that is where we will take a look at the rest of our exercise testing data, and that will be our next step.